So I am going to review the stuff from section 1.4, which I said last time is one of the sections you need to know outside of chapter 4, and also section 2.6. But first, I just want to make sure everyone knows what the deal is with the final exam. So the final, make sure, 30th at 8 a.m. is going to be April 30th. The exam will open at 8 a.m. and it will close at 11 a.m. Once you start, you'll have 2 hours to do it. But in any case, it closes at 11 a.m. You're going to open the exam the same way you normally will through WebAssign. So you'll go to our course, you'll go to modules, and then you'll go to WebAssign. While this is loading, you can go ahead and open HonorLock because you'll need HonorLock as well. Well, there it goes. What just happened? Okay, so your WebAssign is going to look a little bit different. Let me open Student View here. All right, so we're going to go here. We go. This should be more like, well, just give it a second. All right, this is what you'll see. So I think it doesn't show the exam yet because it's not open yet. But once it does open, you'll be able to see it here, just like you normally would. The same way we took exams in the past. But then when it prompts you for the password, that's when you're going to have to go to HonorLock and do all of that, stuff that HonorLock makes you do. So you'll click the you'll come back to Canvas, click the HonorLock tab. You'll see the exam. Now it's not going to open, remember, until 8 a.m. So you won't. Now yours is going to look different than mine here, but you'll on April 30th at 8 a.m. you'll see the exam, and it'll say launch. There'll be a blue button over here that says launch. You'll launch it. You'll jump through all the hoops that HonorLock makes you jump through. Taking a picture of your ID and yourself, and then room scan and all that junk. And then a little window will pop up that says, an HonorLock window that says insert password, or I think they changed the button. So now it actually says click here to insert password. In any case, it should be very clear what that button does, right? Then you'll have that little window open. It'll be a little HonorLock window. You'll pop back over to the exam where it's prompting you for the password. You'll click in the little text box and then go to the little insert password button, which will be open in a HonorLock window. You'll click that. It'll automatically type in that password for you. And then you will just click start, right? So that's how you'll get into the exam. So I'm not giving you the password. HonorLock is giving you the password. So to run HonorLock, you're going to need to make sure you're using Google Chrome. You're going to need to make sure your computer has a webcam. Make sure you have good Wi-Fi too. And what else? What else? You do have a formula sheet, so you can, I believe HonorLock should give you a link. It should, because HonorLock knows you're allowed to use it, so it should when you're jumping through all the hoops for HonorLock, it should show you a link for the formula sheet. If not, just go back to the Canvas page and just manually open it. And keep in mind that this is a 2-page thing, but the first one is just for my finite math class. I just have all my formula sheet stuff together here. So you're only going to be worried about the second page for MS 112. Okay. If you feel better, you can just print this off. That's a lot of my 110 students are doing that. They're just going to print off the formula sheet so that they can have it as a a hard copy there in front of them when they're taking the exam. The exam is going to be shoot, I just looked and I forgot, 14 or 15 questions with one of those coming from 1.4, section 1.4, one of those coming from section 2.6, and the rest coming from chapter 4. So it's like, 85% chapter 4. Everything you need to know for chapter 4 has been covered since this March 29th meeting. So chapter 4 is all in here. And then the things that you need to know for section 1.4 and 2.6, I'm about to cover now. So let me stop screen sharing, turn this on. There we go. Okay, so before I really get going into this review, do you guys have any questions about when the final is, or how it's being taken, or the password, or just anything I just said? You need me to re-say anything? Okay. Let's talk about, sorry, one second. Okay, let's talk about section 1.4, which is solving quadratic equations. Well, I actually don't remember exactly what the name of the section was, but what I want you to be able to do is to solve quadratic equations. Okay, so quadratic equation is something in the form ax squared plus bx plus c equals 0. This is the nice standard form that we like to have because it has a 0 there. That's very nice, right? That's this is the nicest form that we can have. We have a lot of tools that we've looked at for solving these things, right? Because they cannot be solved linearly, or they cannot be solved just via, adding or subtracting stuff over and then dividing like a linear equation can, right? If I take this squared term off, the quadratic term, then this can be solved really easily just by scooting stuff across the equal sign. Not so much when there's a squared term here. So we had some techniques. We had factoring, which that was a whole thing, right? We had like the classic trinomial factoring. We had factoring by grouping. We had special cases for factoring. We had something that we didn't really look at too much, but is still there, is completing the square. Completing the square, which is a difficult method, but it's pretty much the method. But the reason we didn't look at it that much is because you can do this method, completing the square, on a generic quadratic equation like this with no numbers, just a, b, and c, just representing any number you want. You do that method on this, and then you end up with a formula called the quadratic formula. And that's really what I've sort of encouraged you guys to lean on, is this tool that's literally you just have to know how to plug in numbers, right, to be able to solve a quadratic equation, because it's a nice pre-built formula for the solutions, for the x value solutions to any quadratic equation. Even if it has complex roots, this will still get them. So this is what I've been encouraging everyone to lean on for solving quadratic equations. And that's what I'm going to lean on when I do some examples here. And just so you know, I feel like it's pretty clear where these A, B, and C are coming from, but I'll just point it out. The A, B, and C's in this formula are coming from the coefficients here on the generic quadratic equation, A, B, and C. Okay, so let's run some examples. So let's say example 1. Example 1, let's say solve. I'll say solve each quadratic equation. So part A, let's say x squared plus 7x plus 12 is equal to 0. Now, if you recall the factoring way to do this, then you might look at this and say, oh, this will factor really nicely, pretty easily, in fact. And then once we factor it, we can split it apart and solve for each x value individually. But I'm just going to solve all of these via the quadratic formula, just to show you that it can be done for literally any quadratic equation. So let me identify what A, B, and C are. A is the leading coefficient, so it's 1. B is that middle coefficient, the linear coefficient, the number attached to the x, that's 7. And C is going to be that constant term, which is 12. Those get plugged into my formula, so I'll say x is equal to -7 plus or minus 7 squared minus 4 times A times C all over 2A. And now all we have to do is clean this up, right? That's the brunt of the work for the quadratic formula, is just doing the arithmetic to clean it up. So I'm going to say -7 plus or minus 49 minus 48 all over 2. Okay, because, 7 squared is 49, and 4 times 1 times 12 is 48, and that minus sign is still there. Okay. X is equal to -7 plus or minus square root of 1 all over 2. Remembering to do the difference first, right? 49 minus 48 cannot split this radical around that minus sign, so I have to do the difference there, which is just 1, and then try to simplify the radical, which in this case simplifies, I mean, it's like the easiest radical to simplify, right? Square root of 1 is just 1. So I'm getting -7 plus or minus 1 over 2. So in this case, when you get to a solution where the root completely goes away, you should keep going past this point to get the cleanest solutions. If there's an ugly root left in the answer, which I'll work something like that, like what if it was like square root of 7 or something, or square root of 6, something that's not a perfect square, then at that point, all you can do is just split the two answers around the plus or minus, and that's really, you can't simplify it any further, pretty much at that point, right? In certain cases, anyways, we're going to work something like that. But in the case where the root completely goes away, you should keep going as far as you can to get the two solutions for x. So what I'm going to do now is I'm going to split at the plus or minus symbol. So I'll say x is equal to, and then I'll go like this, showing the split, -7 plus 1 over 2, or -7 minus 1 over 2. So you see I'm splitting at that plus or minus symbol. There's only one time you don't have to split, and that would be if the thing under the radical zeroes itself out. If it goes away, if it's just, if it's just 0, if we had 49 minus 49, then this would completely go away along with the plus or minus, and you would only have one solution. But in most cases, you're going to have two solutions, at least in these kinds of problems. So here we're going to have -6 over 2. Kind of made a mistake mark right there. Here, this would be -8 over 2. Just got to know our integer arithmetic there, know how negatives work. And then finally, just simplifying to -3 and -4. So my answers are x is equal to -3 or -4. This would be, of course, the solutions you would get if you factored it as well. And the factoring, I grant you, factoring would be much faster and easier. But the point I'm trying to make today is that any quadratic equation can be solved via the quadratic formula. So it's okay to lean on it very heavily. Okay. So let's try another one. So let's say part B. X, let me think. Let's say 3x squared plus 6x is equal to 7. Okay. So if I want to go ahead and start setting up my quadratic equation, I need to know what A, B, and C are. Does anyone know what, so I'm writing down A and B, right? A is 3, B is 6, but what is C? Does anyone remember what we need to do here before we can actually explicitly identify C? We have to have this equation in the right form. The quadratic formula is based off of the quadratic equation that's set equal to 0. That's like one of the only stipulations about the quadratic formula is that you need the whole thing, the whole equation that you're solving equal to 0. So that all that means, though, this is a very easy thing to fix, is that if anything is stuffed over here, you just move it back across. Just move it back across. So that means C is -7. And that matters. You can see that here, because if you are just going through the motions and you forget that step, then you would call C +7, which would be wrong because C is -7 when you get it in this right form. Okay, so now I'm going to say x is equal to, so it's -b plus or minus square root of b squared. So I'm plugging in as I go here, minus 4 times a times c all over 2 times a. Now let me tell you how, so if you're like feeling overwhelmed about cleaning this up, let me tell you what to do. Don't mess with the thing outside, just -6 plus or minus. In fact, what all you're going to do in your first step when you start cleaning this up, just clean up what's happening under the radical. You can go ahead and, multiply this down here. I suppose that's pretty easy, right? 2 times 3. So write that in, bring this -6 over, bring the plus or minus over, bring the root over, and now you can just focus on what's happening inside. All right, just one step at a time here. So, or one piece going left to right. 6 squared is 36. The next thing I like to figure out is what should be the sign. What should the sign be after the 36? Well, since there are 2 negatives, it's plus. And now I can just ignore those signs, right? So now all I have to do is figure out what 4 times 3 times 7 is. And I'll just ask the calculator because I'm being lazy today. And it's 84. Okay, now next step is when you actually do that arithmetic under the radicals. Everyone following? Any questions or need me to repeat anything? 36 plus 84 will be 120. And we'll just make sure, in case you don't believe me, 120 there. Okay. And now you get into the situation where you're going to have to start figuring out, can I simplify this square root? And this might be a good time to go off on the side and do some side work with the square root of 120. So I'm going to lay my paper here to do my side work for square root of 120. And I'm going to go ahead and get this out of here. I'm going to scoop this up so we can still see part B. There we go. Okay. So now I'm going to, this is side work, square root of 120. You'll probably want to write this somewhere else in your notes because I'm going to move the paper and keep solving this here. Square root of 120, I need to be able to simplify this by hand. I cannot ask the calculator unless you really know how to use your calculator or know how to get it to simplify square roots. I think some can do it. Mine cannot. My model can't do it. Some can though. But anyways, doing it by hand here, what you do is you try to find a factor of 120 that is a perfect square. So I'm thinking like, I know some perfect squares like 4, 9, 16, 25, 36, 49, 64, 81, 100, etc., right? Which one of those sounds like would go into 120? Well, I know 4 will, but let me try some bigger ones because it's always better to get bigger ones. So I'll say divided by 64. Nope, that don't work. How about 120 49 surely won't work, but I'll just check anyways. Nope. How about 36? Nope. How about what's the 25? Definitely not, right? What about 16? Ah, nope. 7.5. 9, definitely not. And finally, I'm just down to 4. Did I skip any? I don't think so. Which is 30. So I can write this. I've found a perfect square factor in 120. Remember, when I say factor, I mean a number that goes into it, that divides it. So 4 goes into 120. So I pull apart the 120 using that 4 here. And then I say, okay, I can pull this apart. This is the, at this point, you may have a more compact way of doing this, but this is like the long way of doing it here. Square root of 4 is 2. Square root of 30, well, that just stays just like that. And there are no perfect square factors of 30, even though it's a fairly big number, but it has no perfect square numbers, factors. So this is as far as we can go. So, any questions about that before I go back to the work here? So what I do is I come back over here and I replace square root of 120 with 2 square roots of 30. So I say -6 plus or minus 2 square roots of 30 all over 6. And I'm almost done at this point. All I need to do now is say, wait a second, both of these numbers up top have a common factor of 2 because they're both even, right? 6 and 2, and this denominator does as well. So what I'm going to do now is say, x is equal to, I'm going to pull a 2 out of both of these, factor a 2 out, so I'll have left inside -3 plus or minus square root of 30. Okay, just pulled a 2 off of the -6, leaving a -3, pulled a 2 off of 2 square roots of 30, which just left the square root of 30, and this is all over 6. So that's going to give me x is equal to, the 2 will cancel, right, with the 6 in the bottom. Whoops, that's a 30. And if I cancel a 2 over 6, that leaves it. So it disappears up top and leaves me with a 3 in the bottom. And that's as far as I can go. I cannot cancel these 3's unless I split the fraction, which you could do, but at this point, this would be a nice, compact, clean answer here. Only other thing you might want to do is, it depends on how the problem is asked. Sometimes you're allowed to input the answer like this with the little plus or minus symbol in between, like this. But more often than not, they want the answers separated by a comma. So the way you would write that is x is equal to -3 plus square root of 30 over 3, comma, -3 minus square root of 30 over 3. And again, we cannot simplify that. It looks tempting because there's a lot of 3's going on there, but there's nothing else that can be simplified here. So this would probably be the most appropriate way to input your answer, like into the online exam, right, where they want the answers separated by a comma. This is probably as worse as it can get with the quadratic formula, because not only do you have a root sticking around, but it's a big enough root that it has stuff buried inside of it, like factors that can come out, and those factors, the factor that comes out can be simplified with the little fraction in the bottom. So that's when the things get, this is pretty much like as complicated as it can get, just because of all the simplifying work that needs to be done, all of the arithmetic that needs to be done to clean up that root, and then to factor out the common factors. Yeah, okay. Let's try another one. Part C. One second, let me go look at something. Just give me 1 second. Okay. Let's say x squared minus 6x plus 1 is equal to 0. This will be kind of similar to the first one because it's going to have gross answers that need to be simplified. All right, let's go straight to it. X is equal to negative b. Oh, actually, sorry, let me write down what a, b, and c are. A is 1, leading coefficient is 1. B is negative 6, and c is positive 1. So let me bring this down a little bit. Okay, so x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. You notice how with the negative b, I just wrapped b in, b is negative 6, so I just wrapped it in parentheses and put the negative on the outside. So I'm not trying to simplify this as I write down the formula. I'm not trying to simplify as I write it down. Even though I know negative of negative 6 is just 6, right? But I'm purposefully not doing that because I don't want to mess up when I write it down, like when I'm filling everything in. Okay. Now I can start cleaning it up and I'll say, okay, now I can say negative of negative 6 is 6, and then plus or minus inside my, well, actually, let me go ahead and get the bottom. Let me write that down. There, 2 times 1 is 2, no problem. Negative 6 squared is 36, and then minus, well, minus 4. 4 times 1 times 1. Okay, I'll back up a little bit here. X is equal to 6 plus or minus square root of 32 over 2. Now again, I'm going to have to pull this square root of 32 off to the side and see if anything can be done with that. Sometimes you'll look at them and you'll just know. Like if it's a square root of 11 or something like that, you know it's got no perfect square factors, then you can just, at that point, you can just comma separate your answers, right? And just split it and separate them by a comma. But here, like so a number like 32, you know it's built from like a lot of 2's, like 4 times 8. You know, there's definitely got to be a square factor in this. In fact, if I think hard, or if I, equals, or if I bust out the calculator and start dividing by perfect squares, I'll find that 16 goes into it. And that means that this can be written as, and again, you may have a different way of doing this step. You may just say that's 4 square root of 2. I like to pull it apart. You can pull it apart around the multiplication and then simplify this part to a 4, and then just stuff the square root of 2 onto the back. So that's going to replace this in my calculation over here. This 4 square root of 2 is going to replace the square root of 32. So I'm going to say x is equal to 6 plus or minus 4 square roots of 2 over 2. And again, this one's going to need to be cleaned up more because all of these are even up here along with that. So how do I do that? Well, I say the safest way to do it is to pull a 2 off of both of these. Not off of the radical, right? The radical is just along for the ride at this point. Pull a 2 off of both of these numbers, the 6 and the 4. That's going to leave me with a 3 plus or minus 2, and then tack that square root of 2 on the back. All over 2. So x is equal to 3 plus or minus 2 square roots of 2. The 2's completely cancel each other out. So comma separating the answers, x would be 3 plus 2 square root of 2, comma 3 minus 2 square root of 2. Let me show you one where there is only one solution. Well, were there any questions about that one? This one is kind of pretty much the same as part B, actually, except that the fraction completely went away, which can happen. Okay, let's look at x squared plus 14x plus 49 equals 0. Oh, by the way, I haven't done any that have complex roots, meaning I haven't done any that require you to deal with negatives under the square root. Remember, that can happen. That can easily happen. But I'm not worried about that. So all of these are going to have real roots, meaning you're not going to need to deal with the imaginary number I. All right, A is equal to 1, excuse me, B is 14, C is 49. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Cool. X is equal to negative 14 plus or minus, draw my square root, go ahead and say over 2. 14 squared is 196. And you'll find that 4 times 49 is also 196, which is fun. That's nice because now what happens is x is then equal to negative 14 plus or minus square root of 0 all over 2. That's just 0. So x is equal to negative 14 over 2 because plus or minus 0 doesn't mean anything, right? You can completely drop that whole part and just get negative 14 over 2, which is negative 7. So x equals negative 7, only solution here. So it can be the case that there's only one solution. These are really nice. When there's only one solution, that means that the root part is going to completely go away along with the plus or minus symbol. So that's probably the nicest case. Okay, let's look at the next section now. By the way, if you're trying to study these, I mean, I gave you some extra problems to look at from 1.4, I believe, or at least one. Excuse me. But if you want more, you can go look at the problems in 1.4, or you could just make up your own. But, well, you don't want to. You can make up your own and then check your work in like Wolfram Alpha or Mathway or whatever kind of online. You know, there's tons of places online you can just plug in these quadratic equations and it just pops out the answer. But you don't want to deal with any that have I in them because you don't need to know that for the exam. So if you're trying to study this in practice, the quadratic formula, what I would say is just make one up, right? Just pick random numbers for A, B, and C. And then go plug it into a site like Wolfram Alpha or Mathway or whatever it is you want to use and look at the answers and say, oh, well, this has I in it, so I can't use that, and then change the numbers. And if it doesn't have I in it, you look at the solutions, then go work it out by hand and see if your solutions are matching. Probably the best way, though, honestly, would be to look at what's already built in the text, because the text is going to have problems that are nice. Let's see. Yeah, pretty much like 29 through 46 in the text. Those should all be good examples that do not have complex roots. Okay. Meaning they don't involve the number I. Okay, let's look at, what are we looking at now? 2.6. All right, you need to know your base graphs. Now, we talked about a few different types of base graphs. I'm going to narrow it down by excluding the rational functions, meaning the 1 over x squared, those functions. I'm counting those out. So you need to know the x raised to an even whole number. What do those look like? So I'm talking about like x squared, x to the fourth, x to the sixth, etc. Those are looking like parabolas, right? And just so this is the general shape, but remember that, you know, as you increase the power, they get more and more steep. They get steeper and steeper. Okay. Then we had x raised to an odd whole number. I'm skipping x to the first because that's a that would just be a linear, like a straight line. We're more interested in the curved ones. That was more of our interest in this section. So these are all having this general shape where the leg over here is pointing down. And then we had, so these are still just base graphs, right? I'm just writing down the base graphs. Then we had even roots. So that's like square root of x or fourth root of x, etc. Remember the root for a square root is a 2. The index there, that number written right, it's technically a 2, but we just don't write it when it's a square root. Oops. And those are kind of like a sideways parabola, but it's only the top half. And then we had odd roots, like cube root of x, fifth root of x, etc. And that was very much like a sideways and flipped over odd whole number exponent up here, like the cube root or the cubes and stuff like that. So it's like this and this. And then remember we had another class with the rational functions like 1 over x squared, but I'm counting those out here. Now, in addition to the base graphs, which should just be like just base knowledge here, we also need to know the what the transformations do. Like what does it do when you add or subtract on the outside? What does it do when you add or subtract on the inside? What does outside versus inside mean, right? So, and then what about multiplying? What about negative signs? Okay, so I'm just going to take x cubed as the example. So my base graph is going to be an x cubed graph, because if I worked every single iteration of these with every single transformation, every single graph, we would be here for a whole nother week. So I'm just going to take this as my example and work the different things that can happen just based off of this one particular base graph here. So if I add outside, that's going to, oh, sorry, I didn't even name it right. I want it to, it's a function, right? So really, I want to name it f of x equals x cubed. F of x equals x cubed. So if I'm adding outside, it's going to be like x cubed plus 1. That's going to lift this graph up by 1. So it'll look more like that. And I'm just going to say plus 1. It's a very easy number to add, right? It just scoots it up by 1 there. What if I subtract outside? F of x equals x cubed minus 1. Well, end up running out of room here. That's going to look like the same exact base graph, just scooted down by 1. So it'll be more like this. Okay, what if I add inside? So what does that mean? Well, f of x equals x plus 1 all cubed. So the plus 1 is inside that cube function now. You see the difference? The plus 1 is outside the cube here. Now the plus 1 is inside. And what that does is it scoots it left by 1, which is kind of counterintuitive. Remember, that scoots it into the negatives by 1 left. Oop, I almost messed this up like this. So these are all just based off of this base graph here, and this one is scooting left. Okay, what if I subtract inside? That's going to scoot it to the right. It's going to take this function and scoot it, this base function, and scoot it to the right. So that's what happens when you add or subtract. There's 2 different cases for each of those, outside and inside. Up or down, left or right. Okay. Then we had, well, yeah, still taking x cubed as the example here, the base graph. So f of x is still equal to x cubed, which is the base graph, which I'll sketch over here again, that base graph. Let's just do negations. A negation outside, so that means, what does that look like algebraically? Like this. What does that do? Flips over the x-axis. Flips it over the, what have I done? It flips it over the x-axis. Sorry, I don't know what I was thinking. Let me redraw that. So this leg is up here and this leg is down here. flips it over the x-axis. Now, go ahead and write that down, what I'm saying, flips over x-axis, because why am I specifying to write that down this time? Because the next one, which is negation inside, is actually going to look exactly the same for this particular graph, because this particular graph is an odd function, which means that flipping it over the x-axis is the same as flipping it over the y-axis, which is going to be this next thing here, but it's not the same for all different types of functions, right? So we need to just make sure that we are noting what is actually happening here to be able to distinguish between, for different kinds of functions, what is actually happening in the graph. So here we're flipping over the y-axis, so taking this base graph and now rotating it around the y-axis. So this leg flips over here and this leg flips over here. So it looks it's the same as flipping it over the x-axis, but that's only because this is a special kind of graph that is an odd function. That was one of the defining features of an odd function, actually. So that's why I'm telling you to write down what's happening, so that when you're studying this for other functions, like a parabola, like an x squared graph, you can know that negating outside will flip the parabola over the x-axis, and negating inside will flip the parabola over the y-axis, which in that case doesn't do anything, right? So there's a lot to say about these negations, because different functions have like special properties. Odd functions look the same when you flip them. It doesn't matter how you flip them. It looks the same. Even functions, they do flip over the x-axis and they turn upside down. But the special thing about even functions is when you flip them over the y-axis. What is an even function, by the way? Like this parabola. If you flip that over the y-axis, it doesn't change, right? So there's these different special properties for each kind of function when it comes to these negation things. So just be careful there. What you should remember is that negating outside flips it over the x-axis. Negating inside flips it over the y-axis. When you go to draw these things, flipped over the y-axis or whatever, if you're trying to flip a parabola over the y-axis and you go to draw it and then you draw it flipped, and then that's when you should go, oh yeah, that's when you should remember and say, oh yeah, it doesn't matter for a parabola, and you can proceed from there. So what I'm saying is it's not necessary to remember those, like the little subtleties for every type of graph in these negation rules. It's just important to remember what each kind of negation does, what axis you're flipping over, and yeah, that's pretty much. So there's also multiplying and dividing, but let's throw that away too, and let's just focus on the shifting, which is adding and subtracting inside and outside. So this page, up, down, left, right, and the negations. For what base graphs do you need to know these things? For the 4 base graphs that I put here on the first page. So these 4 base graphs, know these 4 transformations along with these, so these 6 transformations altogether on these 2 pages. Oh, and know how to put these together, right? Remember that you can take a graph, you can add something inside and outside, or any combination, right? And that'll scoot it, maybe like left then up, or right then down, or left then down, or whatever, any combination, right? Understand that you can do that. You can combine these things. You can take one of these and one of these and stick them together and have a function that's scooting up and over, down and over, down and over, right? So keep that in mind too. Now, let me go peek at something, make sure I'm see. Yep, okay. I'm not leading you astray from what is going to be on the final. So this is it. The rest of the final is all from chapter 4. So this is our last meeting. We don't have class Monday, the 26th. The 26th and the 27th are academic prep days, basically days for me to leave you alone so that you can study. And then we have the final a week from today, so on the 30th, at it opens at 8 a.m., closes at 11 a.m. It's 2 hours, but it in any case closes right at 11 a.m. What else can I say? Don't forget about your WebAssign homework. That's still, that's a fair bit of points for this chapter 2. Chapter 4 homework. I don't know why I said 2. Chapter 4 homework. Section 1.6, which you'll see is floating around in the last homework assignment section. That's just there if you want some extra points. You don't have to do it. It's just one of those topics we didn't get to explicitly in class, but it's just there if you want to get some extra points. If you have extra time to do it, you can get some extra points there, but it's not going to be on the exam or anything like that. Let's see, what else can I say? What else? Am I missing anything that I should say? Exam is given remotely. I already talked all about that through HonorLock. If you think that you're not going to be able to take it at home, or like you don't have a good source of Wi-Fi, or it's too loud, or you don't have a computer with a webcam, reach out to me as soon as you can and let me know, and we can figure out something to get you a place on campus to take it. Okay, do you guys have any questions about anything about the class, the review, final, anything? Oh, while you're thinking of questions, there's the survey thing that Canvas has probably been bugging you about doing. You can do it if you want, right? It's this is my last semester teaching at JSU, besides a couple classes this summer before I go off to do more schooling. So I'm not particularly worried about you guys doing those surveys. So do them if you want, but you don't need to. There's no pressure from me to do them. So don't feel bad if you just keep clicking ignore or whatever. Okay, so any questions? Okay, I will be available on April 30th in the morning in case you run into any issues. So you can just chat with me via Teams. That's usually the fastest, or you can send me an email. So if you run into any issues, I'll be available. All right, I'll see you guys. Well, I may not see you again, so good luck on the final. And sorry, I know I keep saying this is the last thing. Real last thing though, for grades, pretty much well, let's see, your homework is all due April 30th at midnight. So the next day, is that May 1st? I believe it is May 1st. Yeah. I'll be calculating grades that day, so you should know your overall grade sometime May 1st. Okay, you guys are good to go.